Hello everyone, my name is Oswadikari and I'm here to introduce HyperJump. HyperJump is an attempt to integrate continuous and discontinuous locomotion in VR. Continuous locomotion, such as leaning-based interface, can provide naturalistic and embodied experience. They also support path integration. However, continuous locomotion means continuous optical flow, which can cause cybersickness. And if we decrease the speed to reduce the optical flow, the long distance travel can become time consuming, boring, or even annoying. Teleportation, on the other hand, has no optical flow and has been shown to reduce cybersickness and travel faster. Teleportation, however, can cause disorientation and compromise spatial updating. So we propose HyperJump. It is a hybrid interface and it tries to make the best of both worlds. In HyperJump, there is a continuous mode up to a speed of 5 meters per second. And if the user wants to travel faster, then it adds a jump of 1 to 8 meters every half second. So with this interface, the user can seamlessly transition between slow mode and fast mode. Optical flow is always present. However, that optical flow is limited to an equivalent of 5 meters per second travel speed. So with this interface, we want to find out, does the limited optical flow support spatial updating similar to continuous locomotion interfaces? To find out, we conducted a user study. In this user study, the participants started from the red circle and then they traveled to the subsequent red crosses, and from its location, they pointed back to the previously visited location in a random order. So with an interface, they traveled to 4 different locations and performed 14 non-trivial pointings. We used a virtual model of a part of Tübingen, Germany for a naturalistic environment, and we chose 4 non-intersecting paths for 4 conditions. Controller, which used pointed based steering, controller with hyperjump, leaning, and leaning with hyperjump. And these are the results from our user study. First, there was no significant effect in absolute pointing error when the hyperjump was on or off. However, there was marginally significant better pointing with leaning compared to controller. There was no significant effect in absolute ego orientation error with hyperjump on or off, while there was significantly better ego orientation with leaning compared to controller. And finally, there was no significant effect in distance estimate with the hyperjump or the interface. So, what does that mean? We cannot prove the null hypothesis in this manner, but the effect size suggests that hyperjump has minimal effect in spatial updating. Jumps also didn't affect distance estimate. In terms of the interface, leaning had better spatial updating than the controller, which has been shown with previous studies and now verified in our naturalistic environment and task. More importantly, both interfaces used physical rotation, and still, leaning had better ego orientation than controller. So it shows that physical rotation alone is not sufficient for ego orientation, and there is some value of embodied interface. And finally, the map in this user study was kept deliberately small so that all the interfaces will take similar time to finish the task. However, we expect to see the more advantages of hyperjump in a larger map. So for the second phase, we are going to conduct a user study in a much larger map, where we expect the hyperjump to improve efficiency while maintaining the accuracy and spatial updating of the continuous interface.